And Scott, thank you very much for presenting today.
And can you see my screen?
I can.
Okay, then I'll start. Thanks, Margaret, for having me. This is a tool that was developed for National Weather Service training. Dave Hayes and Ray Garcia were the people who did up most of the software, the key banging, but I'm going to be describing it. So it runs on just about any kind of computer you're going to find, but it does a lot of computations on the graphics card. So the more memory and power that you have, the better. And it's still being worked on. So there's some ongoing work to improve the software based on suggestions or things that we find out when we're using this for training. There is a website, the link is here, that includes information on how to, some tips on how to use it. If you go to that, you see it. There's actually a blog and there's some entries there, like how to display NOAA class data in SIFT. So a good way to get GOES 16 data is to go to NOAA class, and I'll show you how to do that in just a little bit. When you open up SIFT, that's what it looks like. Of course, you can move that map around, but the default is just kind of centered on, Kansas City, maybe. And it's pretty easy to access the data. Once you've downloaded the data from NOAA class, you'll get some netcdf files. You just do open on that, so Control-O, just like you're using any other kind of software. And this is what the display looks like when it's loaded into. So we're looking at some band 1 imagery, the 0.47 microns from GOES 16. And it's loaded up at full res. It's not being displayed at full res right now, but if I were to zoom in, and I'll show you that in a bit, suddenly you'd have very nice, crisp, full resolution data, and you can pan and zoom and move around and do comparisons, and I'll show you some examples. One of the nice things is you can probe. So here I've zoomed in, and I'm probing the data there over southwestern lower Michigan, and it's showing a reflectance of 0.318 in the blue band. So something that might be of interest. Maybe the reflectance value isn't that interesting, but if you're looking at brightness temperatures in the infrared, then that can be something cool to look at. So you can load up all 16 channels, and I'll just quickly scroll through them, and you can kind of see what the different channels look like. You can intercompare them, and I'll be doing this with real-time data in just a bit. So all 16 channels have been loaded in this particular example. You can change color enhancements. Anything you really want to do with satellite data, you can do with this kind of software. So when I was scrolling through here, this is just the default enhancement. You have to choose something. But people have their favorite enhancements, and a lot of them have been loaded up into SIFT. So I'm going to do a live demo now. So this is data that's been downloaded from class this morning. If you get data from class, it takes about an hour for it to get there. So I was there around 9:50, and I was getting data from 8:47. So that's not too bad. So you can get the full disk. You can get the full disk scans, the CONUS, and the mesoscale, and there's the link there. To get the data, you have to register but that's free. So let me just exit out of this. So here's what the NOAA class site looks like. I'll just zoom out a bit. And it says, please select a product to search. There are a whole lot of things in there, but you want to scroll down until you find this one here, GOES R series ABI products. ABI is the Advanced Baseline Imager, and those are the products that you're going to get. It says it's partially restricted. That's really not true right now. If you were to get data from a year ago, then it'd be a lot harder. So that's what you would click. Then it takes you to, well, I guess I can click it. It takes you to then you click on Go. It takes you to a place where you can decide what times you want, what satellites. Of course, it's just GOES 16 right now. GOES 17 is going to be sending data shortly, and different channels, different sectors. But let me show you SIFT now. So this is data from this morning, and this is something I loaded. I loaded it up because I didn't want to waste those 30 seconds it takes to load. It loads up really pretty quickly. So here's the weather from this morning. This is 13:42, so that's 8:42 p.m. And the big weather, at least for here in Wisconsin, was the convection we had overnight, so some nice thunderstorms. And I'll just pan and zoom around. One of the things I like to do about this is just compare the bands. So this is band 1 and band 2 and band 3. And there's a huge difference between band 1 and band 3 that's related to how reflective the land is at 0.86 microns. That's band 3, the veggie band. And here's, oops, this is band 2, the 0.64 microns, which is in the visible. Then the 0.86 is in the near infrared, and you'll notice a big difference there. Then we go to the cirrus channel, which is where you can only really see high clouds in a moist atmosphere. So we just scroll through all of these. Here's the infrared. We have the 3 water vapor channels. I didn't notice that this morning. So some nice evidence of cirrus contrails over Mississippi from this morning. I'm not sure where they're flying to or from, but there's a little bit more moisture in the upper atmosphere here, so the cirrus contrails are sticking around, and GOES 16 is seeing them. Here we have the 8.5 micron, the 9.6. This is the 10.3, which is the clean window channel, showing here are some cold cloud tops. If we want to figure out how cold they are, we can hit the probe, and we see it's 60 below 0 in Celsius, and just scan around that. One of the things I like to do, maybe this will be the last thing I do for this telecon, not necessarily the last thing ever. You can make a little region, and then you can compare different bands. So we've been looking at the layers here. I guess I can pop the layers out. One of the nice things about this is you can move these windows around if you want to. But we're looking at the area probe graph right now, so I'm going to pop that one out too. Come over here, make it bigger so you can see it. This is all written in Python, by the way. That's what Dave and Ray are great at. I couldn't write Python well, I probably could, but not very well. So I can compare, for example, band 13. Let's compare band 13 and band 15. So the clean window versus the dirty window. And if we move the cursor around, so you notice there's a white dot there that's moving around as well. So it's saying, if you're looking on top of this very cold cloud, the temperatures are very similar. If you're looking in where it's relatively clear, well, I was hoping I'd see, well, let me change this, give you a different region. So the 13 and 15 have different sensitivities to water vapor. So that's what I wanted to show you. So this is comparing 13 and 15 in this very small little region over Iowa. And you'll notice that band 13 is should be a lot warmer than band 15. That's because energy that's leaving the surface is being absorbed by water vapor, and it's being remitted from higher up with band 15, so you get a colder temperature. Let me do one last thing. I'll make another region over these clouds. So you can compare brightness temperatures. You can also compare reflectance. So here we have, I'm going to compare band 2, which is the visible, with band 5, which is the snow ice channel. And you see a huge difference in the reflectivity. Band 2, very bright. Band 5, which is at 1.6 microns, which is where energy is absorbed, is very cold. And if we go back to those, here we have I'll have to get rid of that, but here we have band 6, and you'll notice these ice clouds over Lake Michigan are very dark because they are absorbing energy. But if we look at the visible image for the same time, very bright. So that difference between bright ice clouds and dark ice clouds. Then there are other clouds that aren't quite so dark. These clouds are made up of water droplets, so they're reflecting most of the 1.61. They're not absorbing it like the clouds up to the north. So that's really all I wanted to show you this morning. As I said, if you go to this website, you will see ways to download things. So there's a Windows installer, a Mac installer, and a Linux version. So the Linux is just as gzip tarball, and you can download it. Then you go to class, get some data, start playing around with satellite imagery. That's all I got, Margaret. I'll put my last slide up there. If you have any questions. send me an email.
Thanks, Scott. That was great. How convenient we had a thunderstorm over the area today.
I know. It's like I planned it.
Yeah, good job. So I've unmuted everyone, and I see Becky Reed commented in the comment book, love how this uses the same day data. So as Scott said in the beginning of the talk, the data you get from class is less than an hour old, just under an hour. So that's nice.
Right, so if you have a thunderstorm come through at night and you want to show it to your kids during the day, and show them at different wavelengths, teach them something about how radiation behaves in the atmosphere, that's something that's really doable with this.
I have a question.
Okay.
Go ahead.
Is there a handy dandy like one sheet that gives us hints like the wavelength of the band and then what we can see in it and why?
There are fact sheets for each of the bands. Margaret, I can send you the URL for those and you can send them around to people on this call and we can append that to the, let me see actually if I can remember the URL. But yes, there is stuff out there that describes a different
Well, I'll just talk for a second. There's one for each band, like Scott just said. They're on the GOZAR page, but I think they're all 2 pages long. Some of you might remember that we developed some web apps to explore the different bands in GO16, and as you use that along the top, it has 1-sentence descriptions of what you might expect to find in each band. But I agree, Luann, it'd probably be good just to have one sheet, compiled. Oh, this is the links to them, right?
Right.
Okay.
So, for example, looking at the snow ice band, we have something that looks like this. I mean, it is 2 pages.
That's okay. Even having the nicknames and things like that is very useful, I'd say.
So I got to this site through Tim Schmidt's handy dandy list of links. So that's sims.edu/goes/gosdata.html. And he has Tim Schmidt, who's a NOAA employee or a famous NOAA employee here. He tweets as Goes Guy. He just has this list of everything you want to know about Goes 16 and soon to be Goes 17 as well.
All right, I see a question in the box. Just a second. Oh, I'm going to read it from Becky. I can see using these layers to teach interpretation of what you can see. For example, Scott knew right away what a contrail or thunderstorm looks like. Would be fun to have students do a scavenger hunt with the images. Ooh, that's a fun idea. So anyways, the wheels are turning, Scott. Thank you very much for this presentation. It was exciting.
Glad to hear it.
Any other questions from anyone? I'm going to get it downloaded on my computer and figure out how to use it, Scott. Thanks for getting us started. All right, thanks for tuning in, everyone.
Bye, all.
Thanks.